Thank you so much. Good morning. Good morning. Okay, good. Seems like everyone's had a late night. Good. Welcome. I'm getting old. I'm going to hold on to this, mostly to stick to the script so I don't make this keynote a 3-hour one. What I was going to be talking about today is a topic which is very near and dear to my heart. Wrong way. Is how do you move fast and don't break things? Because I think each one of these things are interesting to do in isolation, but to do them together poses some interesting challenges, opportunities, and we've had a fun ride for about the last half a decade where we have, I think, done this, and we think we have it down to the point where we would like to share this with all of you, so you guys can get a perspective of how we try to do this at Google. But more importantly, you can help us make this even better going ahead. Quick thing, GTAC. I mean, we have last time we did this was in New York. It was widely successful. The New York one was based on a theme. I don't know how many of you were there. And we somewhat felt constrained with the theme, so this year we decided to keep it open-ended. We roughly had about, this time we had about 1,500 speaker applications, which was roughly about 3x of last year, which to us gave us a signal that the community is still very much engaged with GTAC, which is a great thing. That really enables us to keep doing this. Out of the 1,500, about 200 were Googler applications and about 1,300 were external. And of those, 250 of you are the unlucky ones or lucky ones. You'll find out in a couple of days who get to spend 2 great days in this room. And the speakers, we have about 15 speakers. What do I like about GTAC? The booze is great. We can't put it on the slide. Oops, this is recorded. On a more serious note, I think what has amazed me about GTAC is to really get a chance to interact with most of you guys from the industry. And it's an interesting variance in how testing is approached differently in different industries and different segments of the tech industry. And I think we've valued at Google at sharing what we've done within Google, but I think we've gained more from learning from the experiences some of you guys have shared at GTAC. So again, thank you in advance to all of you who are going to be talking about, the other speakers are going to be talking about stuff. So why am I here? Yeah, I've become one of those guys who spends a decade at a company. But Google's a pretty good company to spend that decade at. I'm over the years, due to the kind of work I've done at Google, I'm super passionate about, again, the balance between velocity and quality, because it's almost like a two-edged sword, and you need to balance that. And yeah, I think I just want to be able to share with you guys what we have done. Quick history of my career at Google. I started about 10 years back leading testing efforts for Google Desktop. There used to be this thing. There was a time people used to build software for desktops. So did Google. And then I moved on to leading efforts for everything Google, anything Google that you installed on any operating system. Toolbar, desktop, Picasa, so on and so forth. After that, I moved on to Gmail, which was great. For the first month, I literally tried to figure out how to find the DOM on Gmail, but then I realized I couldn't. Then after about 3 years on Gmail, I lead testing efforts we bucket these projects under an umbrella called social at Google. But projects like Google+, News, Blogger, Hangouts, Voice, etc., things like that. So very quickly, some of the things I My first automation project at Google, I called it MAD because it sounded like it was mad. But we had to create content, a lot of content which we could stress test the Google search appliance and Google desktop with. And so it was fun UI automating Word, Excel, AIM. I don't know how many of you even remember what AIM is, but AIM. Back then, Google used to use a variant of Bugzilla as their internal bug database. It was running under someone's desk. That was Google 10 years back. It started getting really slow because turns out 1/5 of the bugs on the bug database were from my team. So she's like, yeah, you guys need to take care of this. And then it kept getting slower, and I essentially, one fine day got sick and tired of it and just made it 10x faster. What did I do? I just moved it to a faster machine in a data center. That helps. But this one does what technology can do, I guess. I worked on a 20% project called Survey Tool. The reason I talk about this is this was my first real-life example of how not to do things, in terms of how this grew organically, much to initial joy, later to dismay, gained traction. In that day and age, there was no App Engine, no Google Forms, no Google Plus polls, what may. And so it grew through the point that at one point, Google HR wanted to use it as the tool for our annual survey. Within literally, I believe it was less than 3 minutes, the tool melted. After we sent out this email to Googlers, I spent the next 2 weeks pretty much like recovering data, and then I happily retired the tool after a month. So, but that was a good learning experience. And one of the reasons I am doing what I'm doing, and I like test engineering is when I was doing my bachelor's, I worked with a buddy, and we worked on a microprocessor control pick and place manipulator, which is a mouthful way to say a robot. But that really gave me a perspective that while software is great, hardware really, for those of you who work in hardware, I salute you guys. Hardware is a lot more difficult to mold. I almost remember ending up spending 10x more time. So what is test engineering? We tend to think we have a dual purpose at Google. We think we want to build the infrastructure and tooling that is going to enable us to test things at a scale that no one else tests things at. And the other focus we have is we want to test and automate projects, right from things like the autonomous cars to things like glass, to things like, one of my teams tests these. I like to use this, like how blue is your blue in terms of photo editing software, which is a very tricky problem to automate if you come to think of it. So, but that's kind of how we think test engineering at Google is all about. This is how Google looks from the outside. Everyone's like, yeah, this is the world of Gmail, Chrome, YouTube, free food, shuttles, massages, paddle boats. Wow, it's awesome. I'm sure it's probably a fun place to sit and code too. And it is, depending on what your definition of fun is, and what part of the code base you are in. But this is more like how it is, or surely does feel at least 3 of the 5 days of the week. I guess great things come with great pains. I don't know if that's a saying and I made it up, right? But the rich products, we have great products which have rich integrations, but that leads to pretty interesting and complex stacks. We have legacy code bases, and the moment this resonated with me was probably a few years back when I was on Gmail. I wanted to add a feature in Gmail to integrate this thing we have called Google Feedback into Gmail. You probably, if you go to Gmail right now and say send feedback, and I was like, yeah, that should be a 2-day thing. I'm just adding a module. Every feature in Gmail was a module, and I'll have it. Turns out I added a module, but turns out, of course, there was a lot of refactoring which had to be done in another module. And then when I did that, there was race conditions between the module. And then turns out you have to handle the JavaScript. You have to lazily load it. So you also have to ensure that the JavaScript is not too much because you're causing every user to download this every day. And then you have to write a unit test, and then you have to write a UI automated test, and then you have to write an integration test. By the time I was done with all of this, it was 2 months. I was like, wow, that is shockingly sad. I did get that done, but I very rightly went back to all the guidelines and principles we had in terms of how to write a feature and what are the things you need to do, and revise that and made it like it was good to get that perspective. So that's kind of really, I think, a lot of what Google is. Why this slide? I wanted to take an opportunity to highlight. I mean, the code throughput at Google continues to grow linearly. Ever since, I think, Ari spoke about this in the last keynote, and I've been kind of tracking this metric. I like graphs, so tracking this metric, and I've been hoping or assuming that this number would, like this line would actually slow down as we add more people. Bigger companies things get harder to do. That's kind of what you hear. Except at Google, that doesn't seem to be the case. Another interesting tidbit I found, I think this is probably true for every tech company in the, I guess, but it's interesting to see the peaks. Like, there's a peak right before the holidays, after the holidays, and right before Google I/O. So kind of shows through, yeah, it's working as intended. That's what engineers do. Yeah, I got my slides together like 5 a.m. yesterday, right? So that's what happens. And the trend down correlates too. I mean, it's the holidays, but I have no clue who's still checking in those 10,000 CLs. Who are those people and why? Yeah, so that's something we got to fix. That's way too much code going in when you shouldn't be getting code in. Because we've had this, Larry strongly believes in velocity, and we've had a very sustained push over the years on velocity, and we've made a bunch of things around that. That in turn has made us really efficient in how we do our releases. And we've had a bunch of other new product offerings, Google Fiber, things like balloons and whatnot. We almost, but it's still shocking to see we are doing almost twice as many releases. I think this is another testament to, I mean, I want to give a shout out to the release engineers we have at Google. I think they have done an incredible job in automating a large part of our release tooling and workflow to make it really easy for the teams, individual teams, to really sustain themselves in a lot of the tasks needed for release. Of course, our SREs rock. I mean, while we continue to push out all these releases, they ensure Google and all of our infrastructures almost like stay up always and have a very high availability. Google actually publishes this number on our apps dashboard for our apps, and it's kind of insane, the availability we have. So I like memes. I had a lot more memes. Legal made me take them out, but some stayed. As I've been talking to teams within Google and to folks in the industry, I think a theme emerged to me. A theme about, when I started hearing, or I hear Googlers who leave Google and join startups, and they're like, wait, we kind of feel stuck. We are a startup. We should be able to release quickly, right? And I mean, like a lot of people end up having long release cycles. And the definition of long can vary from a few weeks to a few months. But as a result of that, everyone then wants to get stuff in because they're like, wait, the next release is like ways out, so let's get this out with this release. But that, in turn, essentially, I call it a lack of discipline. I mean, it leads to further problems. It leads to further regressions because you're trying to put in stuff which isn't totally baked. It leads to delays. And that in turn is once you are in this, it's kind of a hole you keep digging yourself into. Once you're in there and if you encounter problems, you're so deep in the hole that there's no way to isolate it. The only way to get out of that is fix that problem and fix it and work around it. The context, this slide is important because this slide is maybe the reason why you guys are going to be sitting here and listening to me for an hour. About a bunch of years back on Gmail, we suddenly realized that we need to iterate faster. While what we thought we had a pretty good release cycle, which was weekly, we realized that even though we have weekly cycles, by the time our code makes it to prod, from the time it's cut, it's checked in, it's 3 weeks. So while we were cutting weekly, that code took 3 weeks to get to prod. And that had a bunch of problems. That model had a bunch of problems because it hindered our ability to react quickly when we needed to. It also meant that there were 3 parallel tracks, which means if you had found issues, if you find issues somewhere, you have to ensure you down integrate them on all the branches. There are conflicts, and it's just one specific example I can remember is we pushed a certain Gmail release to prod, and there was the initial page load, I guess the inbox, when you load the page, it slowed down by 20% on IE. We had a laser focus on latency, and we still do at Google, and so that wasn't acceptable to us. We did have what we thought was a state-of-the-art regression system, latency regression system, which could actually help us detect regressions of even 25 milliseconds. But that thing didn't show a blip, but in production we saw a big spike. And then that led to an interesting wild goose chase, which eventually after 2 months because then we were iterating on production, it further accentuated the 3-week delta problem we had. And not to mention we were literally pushing code to our prod users and continuously updating it. After what felt like a 2-month goose chase, we narrowed it down to a change list, which introduced a pseudo hover rule, which in IE causes the entire style sheet all the rules to be reevaluated every time you move the cursor just move the cursor from one element to another. And the reason our system didn't catch it is we didn't have hover-based automated tests back then, because they can be tricky to automate. We did get it back in there. But that's kind of what really was the aha moment for us, and we said, this isn't great. We need to iterate faster. We need to ship daily. And that's how we set about this mission. Okay. We'll call this a bio break for the deck, I guess. Oh. I think this is the next, yeah. Okay. Moving fast is good, right? Everyone likes to move fast. But I wanted to add a bit more color to that. Innovation is no longer just the sexy thing to do. I think you need to do it to survive. We all know what happens to companies who don't innovate, especially in the tech industry. It also really is a great way to retain and hire talent, because people like to work for companies that are innovative and that move fast. And I think moving fast really enables you to do that. The ability to react quickly to critical bugs is huge, and I think moving fast gets you there. This is a chicken and egg problem, in my opinion, where you can't move fast. You can't react quickly till you move fast, but you can't move fast till you don't know if you can react quickly. And at some point, you just have to take a leap of faith and hope for these two to come together, and they do. We've tried this umpteen times, and it's come through in some way or the shape of the form. In some cases painfully, in some cases less painfully. Another side effect of moving fast is productivity is automation is a key ingredient to making this happen. And having if you want to move fast, you have the automation in place, which means if you're making changes in your workspace, if you actually write code that doesn't compile, you're immediately going to find out about it. If you're writing a code where you break a test, you will find out because the tests are continuously running in the background. And I talk a bit more about how we do that. Or if you try to check in a change list without tests in it, we have tools at Google which actually will yell at you, though our human reviewers do a pretty good job of doing that too. And now I think this came about in the last couple of years. We have tools at Google which show incremental code coverage for every change list, which I think is extremely useful. Lastly, I think why moving fast really helps is it helps get the focus on code health. I think code health really helps. In my opinion, every software has product has a 15-year cycle. It's 0 to 2 years to build it, depending on how complex it is. About 7-year shelf life, and then 3 years it's in maintenance mode, and then there are the last 3 years where it's in deprecation and migration mode. Having the focus on code health right from the start really makes this journey on the later part a lot more easier. We know by experience on Google where we've had to deal with this on projects which didn't have code health and had code health, and it's a day and night difference. So again, that's why moving fast is good. But breaking things isn't, obviously. The most important part is, we owe it to our users to ship high quality products. And all companies and businesses do. Unbaked features really lead to a crappy user experience. Or if you ignore quality, products just build up bloat, feel clunky over time. And at the end, that doesn't result in successful products in the long term. It also really helps. A lot of big tech companies are getting into this phase where they are having a hard time shipping, keeping, their launches slip into years. And I think if you have the focus, really, the one way to not get in that state is really ensuring that you have the focus on code health and you move fast, but you don't ignore quality. So Alistair is here somewhere. Yes. So I'm borrowing this slide, this image from him, because over the years I think I found this a great way to communicate to people what I think about my testing philosophy or automation philosophy. I believe a lot of teams and or companies, when they talk about automation, there's a lot more emphasis on UI-based automation. And that is unfortunate because, in my opinion, UI automation is actually the hardest thing to do with all the moving pieces. Very often people just don't stop at the UI automation. They want to test the whole stack. My litmus test is I know a team is doing too much UI automation when they're catching the null pointer exceptions via the UI test, essentially, right? So, so I believe, this cone needs to be inverted in more teams than not. Manual session-based testing is, in my opinion, a fancy way of saying exploratory testing. But I believe exploratory testing is great because I wish my teams can do more of it, because your automation is hitting the same code paths over and over again. And exploratory testing is the way you're going to be hitting these other code paths which don't get excised otherwise. So I strongly believe that if the testers are rerunning the same set of test cases over and over again, those need to be automated, unless in rare circumstances the return on investment is not there. API tests are, I think, great bang for the buck. These are relatively simpler tests to write if the APIs are defined cleanly. They are almost always stable and almost always have a binary signal. Everyone likes integration tests. Everyone's like, oh, more integration tests, more. But I've seen beyond a point, integration tests stop being an asset and become a liability because the signal to noise ratio flips. You just have too much noise. So you want to have integration tests, but you want to have a healthy dose of it and not too much. The component tests are essentially, if you have a stack, you start isolating, and I talk a bit about it later. You test each components in isolation and fake out the other things, which helps you really not run the whole world in terms of tests. And yes, unit tests, of course, are essential. Google's always had a high bar on developer testing, and I think we continue to do that. So this is the rest of the slide is going to be talking about this flowchart, so I tried to take a step back and summarize what are the things we did really to take our journey of moving fast and not breaking things. I could think of 10 things. Let's talk about them. So the first one is what I call push on amber. But before we talk about that, I want to take a detour and talk about push on green. This should be a concept most of you would have heard. Kent, I think in 2003, came up with this concept. And I think it's a great one. If your company and your team is not doing this, by all means, please start with push on green. At Google, what we started realizing about half a decade back is push on green was in some cases starting to stop, not enable but limit us in what we wanted to do. There are some teams which had tests which were dependent on servers which were changing under the hood, and the test would fail, but it wasn't really. The test was failing, but the product wasn't, and should you really be slowing down the product for that? Or we would actually find a bug, but the bug was in the back end, in the stack, it was 2 levels down the stack. Should you be blocking the entire stack from going to production for a bug at the 3rd layer of the stack? So we thought it was time to take more risks and do what I call push on amber. The expectation we set and we mostly meet is we say if you check in a change list at around 4 p.m. today, it will be live in production at 4 p.m. tomorrow. This really helps us ensure. And I want to actually take some time and explain a bit more how we get there, because most people are either shocked or fascinated by this. We'll see which camp you guys are in. We have hourly snapshots of our essentially of our stable top of head, we call this fish food. I talk a bit more about this later. At around 6 p.m. every day, we take the latest snapshot and we graduate it to the next day's prod-bound release. We have a team of calibrated testers who we have worked hard on calibrating the product, who immediately jump on this candidate, if you can call it that, and over the next 4 to 6 hours, run a combination of regression tests and exploratory tests. And I think at an average, even with all the automation we have, at an average find 3 or 4 regressions. We have a simple rule: every regression is a regression and has to be fixed, because otherwise you start going into these debates of what should be fixed, what should not be fixed. We have another set of folks who, once they know these bugs they start culling through the list of changes and actually try to isolate what caused these problems. Again, that's a lot, and this was an aha moment for us when we did it. This is a lot easier to do with daily snapshots, or arguably hourly snapshots, because we have the data, than to do with a weekly one, where at times we would have excess of 10,000 change lists in a weekly snapshot. We know what those changes are. We essentially revert buggy code, or what we call internally rollback. We down integrate those fixes. We then do what we call smarter, I like to call smarter regression testing, where we don't rerun the entire thing all over again. We just regression test the affected parts of the code base. We, of course, do not bypass critical tests, around ACL, data, stuff like that. Of course, all of our automation reruns all the time, because automation is cheap. We just need to throw machines at it. So all the automated tests run at every step. We have also done some experiments along the lines of, we have actually instrumented our servers to help us assess the coverage of our manual and exploratory testing. Because while it's great to have numbers of your automation and your coverage, that really gave us an insight of, wait, we are testing way too much in this area. We're not at all testing way much. And we compare it with actually the code, where the code base is changing, and actually use that as a way to further refine how we spend our time doing exploratory testing. So that's what I mean by push on amber. I like to, my mantra mostly has been I've been telling the teams I work with, don't catch bugs, but prevent bugs, because I think that's the only way to stay ahead of the curve. Too slow. So this is important because I think the only way, trying to figure out how to phrase this better. I mean, we essentially want to ensure that you are preventing. You are actually, the ideal situation is the checked-in change list produce a perfect code, and while you can't get there, you want to get to a point essentially where you prevent, like you catch as many of your bugs as like you don't. They are prevented from being checked in. This is the point where I go to my notes, because as I told you, I'm getting old. Yeah, so for example, so how did we do this? I think one of the ways we did this is we invested in what we call Hermetic automation, and I talk a bit more about that. But we essentially said we are going to test our system under test and fake out the other servers it talks to in the stack. So that way, essentially the way to think about it is if a change list is going to cause a null pointer exception, my example from the old days, it will actually, and if you have a Hermetic test which brings up the server, it will not let the change list to get checked in the first place, because your server is not going to come up. So it doesn't even get in, and so you're not like dealing with like suddenly your staging server not coming up or stuff like that. Over the last couple of years here, we have taken it to the next level, where we've actually started recording our responses for some of these fake servers, which also helps us get our tests even more faster. And I'll talk a bit more about why fast tests are good. Just going to go by this. Okay, so what is a Hermetic test? If you Google it, it says complete and airtight. I think this is a concept on which I think I've made my living at Google. Again, when I moved on some of the projects I was frustrated at seeing tests randomly switch from green to red and back to green. Again, I don't know how many of you have experienced that, but tests it's like watching Christmas lights on a dashboard. And it didn't help 1 ounce with respect to motivation, like telling people why you should write automation. Not to mention when you talk to software engineers, that why they should, like why automation is good and why they should in turn also write UI tests and integration tests. So for a good year or so on the initial project, again on Gmail, I didn't really have a great solution, and essentially we just didn't write any more automation because we need to find a better way to deal with our automation. So there was temporary pain. My definition of a Hermetic test has been, if I'm on a flight, I should be able to run my test and it should pass. Except now, like in the last few years, they have Wi-Fi, so you can write non-Hermetic tests in airplane. But that used to be my litmus test for years, and I would actually do that. In the initial days when someone told me, wait, we have a Hermetic test of our project, the next time I would be on a business trip, I would try running that on a plane. And it would mostly work. So that was awesome as a litmus test. Because I think when you're not talking no network connection, it really isolates a lot of the flakiness you see in a lot of these end-to-end tests. A bit more about Hermetic tests. So this is essentially like a complex web app has a lot of servers under the hood, right? There's the front-end server and a bunch of other web servers. So end-to-end test at Google is typically something which makes a request to the server, gets the responses from these other backends, and gives you the end result, right? But the problem with this is a lot of these backends introduce variance, flakiness, there's network. This is what leads to a lot of the fun, interesting flakiness and debugging sessions a lot of us have. Okay, So when it comes to, so what we did essentially is we designed Hermetic servers. And again, we said it's a server in a box. We're essentially going to try and have our entire test come up on a box. It can be on different boxes too, but if it's in a sealed network, we start the system under test. The client, it talks to the test client, it makes the request via the test client. We essentially fake out, we just use the in-memory data store. That way you reduce all the complexities out, and this leads to a test which is a lot more stable, and it also, the logging module we have actually helps us pinpoint where the issue is. And like we have a similar Hermetic test for the other backend and so on and so forth, if that makes sense. So, yep, that's the Hermetic. So, pushing, so another thing is pushing, like we realize we can't do it all, and I'm sure this is true for a lot of you too. There's a lot going on, and you don't try to do it yourself. Like I like to say, spread the love of testing, right? When I started talking to a lot of these software engineers and asked them why they don't write automation, they essentially said the framework's just too complicated. Or wait, I'm writing my code in JavaScript, and why are you making me write my test in Java? I want to write the test in the same language as the application. So we invested what felt like almost a couple of years, maybe it was a bit less, in building, baking in automation frameworks within our tools. The automation compiles, it's a feature essentially of the product. It compiles with the product. Which means your automation, no one can break your automation framework, right? Because it compiles with the product. We of course ensure mostly that doesn't ship to the end user. We've ended up doing that a few times, but we've learned and not to do that. So that's really helped us getting the software engineers to get involved in writing the tests and owning the automation they write. So this particular flowchart, again, I think most good things in life are accidents, and so this was an accident. This might be one of the most important things I've done at Google from a prioritization perspective. We just had too much going on Google+, right? It's like we launched 100 features in the first 100 days, and there was no way we could test everything, and the onslaught just kept coming. And so I was just trying to figure out how do we scale our testing efforts? Like what do we do? And I literally, this was just thinking stuff aloud on a slide. But then few folks stumble upon it and they're like, oh, this is great. Yeah, we'll just do this, and this helps us figure out what we should test and what we should just make the PMs. So a lot of what this led to is it helped us define where we want our integration tests. This also helped us as a byproduct throttle the number of integration tests. Again, in an ideal world, it would be great if every feature had an integration test, but I think they come with a cost. So actually, this helped us focus on having integration tests for the right features. It also helped us really get everyone involved in testing. Like like a lot of product managers and software engineers were actually excited and collaborating on test plans, doing bug bashes, and like we really made it an effort to make them self-service. And to date, this is how we continue to scale. Which allows us to really focus on fewer things but do it better. Okay, I'm going to speed up a bit. This is important, delineating product releases and features, because this helps disengage the release train from feature changes specs, because they keep changing. This also helps that your features don't have a hard dependency on each other. If one feature is not ready to launch, you just don't flip on the experiment and it doesn't launch. Like when we launch, essentially what is a product release? When we launched last week, we launched Inbox by Gmail. Some of you might have invites. Others want invites. Grab the Googlers here, torment them for invites. It's cool. And like a feature would be like Google Plus recently launched like the polls feature in Google Plus. So that's kind of what I think the difference between these two things are. It also helps us really launch a lot of things silently. because Google does things at unprecedented scale, and this lets us actually figure out how a new backend or a new feature and the RPCs it generate is going to fit into the current stack, which in some cases is barely hanging there by the thread. So this helps us do a lot of like, if I were to say invisible testing under the hood. And more importantly, if we find we launch a feature and it has a critical flaw, we just turn it off because it's an experiment or a flag. We can just turn it off and not have to do an expensive binary like a release rollback or roll forward. So this has been something which has really helped us, enabled us to take more risks too. And I just realized I spoke through this slide. So productivity, why is this important? Yes, users come first, but you need to take care of yourself and your product team. If the team is not happy, they won't do good work. They will, and eventually result to not so great products and unhappy users. So I have this dream. I sound like Martin Luther King, but it's invisible tests, right? I mean, if stuff works, you just don't notice it. It's basically, it works. It's like it's your car. Yeah, it works. You're not like, you don't know under the hood how many things get switched or whatever. It should just and we are getting there in a lot of places. We are actually at a point where we have now under 5 minute UI automated tests on some of our projects. That includes the whole shebang: build, test, setup, teardown. And we are trying to figure out how to like scale this at a Google level. And a lot of tests. I remember someone senior at Google once telling me, tests have become you need to ensure that tests stay an asset and don't become a liability on your liability. So I think that's really important. I think flakiness, I have a personal belief that flaky tests are worse than no tests. And I know we have a few talks around flakiness, so I'm interested in seeing what other people have to say. But when I joined a particular team, they told me they have thousands of automated tests, and I was excited. I'm like, what? And then I'm like, wait, where are they running? Oh, they're like, oh no, we have them. Only like 70 of them are running. I'm like, wait, what's wrong with the others? They're like, yeah, they're like this Christmas tree thing, right? So I'm like, yeah. So I think that is what really is a big productivity killer. So yeah, I just don't attack, kill. I don't know. Kill is a hard word, but yeah, bad tests are terrible. Are like plague. You need to. In my opinion, there are two kinds of bad tests. Maybe there are more, but slow and flaky. I mean, when you want to move fast, ship to production daily, you need to have fast tests because you want to run your automation at various steps of these thing. And if you have slow tests, then that doesn't help. Even one flaky test, if you have 10,000 tests, even one flaky test out of that is going to cause a submission to fail. So it doesn't matter if that is just 1 or that is 10. I mean, so that's kind of why flaky tests are horrible. So we really have a laser focus on this. Like a recent example on one of my teams, we knew over a few quarters we knew we had a bunch of flakiness that creeped in a particular area, and we actually had a bunch of fixes lined up. So again, going back on the philosophy of tying everything behind an experiment, we made a bunch of changes and actually put it behind an experiment. Because the other thing is, I think some of this work at times doesn't get as appreciated as it should, and one way to do that is if you actually quantify its impact. So we actually, rather than like just making incremental changes, we did in our own little ecosystem, but then we turned it on via flag switch, and so like the graph clearly shows that the flakiness really went from like the downtowns to the suburbs, I guess, whatever you call it. Another thing which one of my teams has done, and we wanted to name it Robocop, but there are already like 50 Robocops within Google. Like it's a pretty common internal project name, so we call it Robo Sheriff. It's the goal with this is to take the source, to inflict the pain on the person who made a test slow or flaky, and not the team. Like if you like, so we have this thing automatically just like in the background keeps running and collecting data. I believe we have the threshold set at about 3 flakes in 100 runs or something. But it automatically pulls a flaky or slow test out of the critical pre-submit or continuous build. And it logs a bug, so you're not just ignoring the problem. We are super close to having, where's Jen? But yeah, we are super close to having culprit finding in there. So again, we'll be able to actually find out what the change list is which introduced this problem. And then when things actually get stable or fast, they automatically get put back in. And we sync it with everything. And of course, we have a blacklist of like critical tests which whitelisted. Like you don't take out the ACL test no matter what. If it is flaky, you fix it. You don't like ship without the ACL test. So that's something exciting I think we are doing. This will circulate over at some point. You don't know where you are going till you know where you've been. I don't know if that makes sense, right? So I mean, it's a fancy way to say metrics. I like metrics which can be automatically generated. I hate metrics which you have to put on a spreadsheet and calculate every week manually, because you just don't do that after like a few weeks. I think fortunately Google has good tooling and it's improving exponentially right now in terms of metrics. So I'm not going to read out each and everything on this slide, but kind of tells you guys like the areas I think we believe are important areas for us to keep an eye on. Again, the goal is to move fast and like don't break things. The two things which are red, and I want to explain why they are red. Wait, why is it bad to have more automation? So by the way, that's 114,000 days. Yeah, so and think that equates to, I don't know, but yeah, it is basically, if you calculate the amount of time our automation ran, that's what it equates to in this year so far. And I actually grabbed this data probably 3 weeks back. That's great. In a way, you have more automation. That's bad because we believe that as we keep adding more automation, we want to make it more and more efficient. Our tests need to get more and more faster. We want to 5-minute tests are great, but really it's code. It should just like compile and like your test should be 10 seconds if needed. So as we add more tests, we actually want to add more automation, but we want to reduce the amount of time our automation runs. We want to get smarter at how we run it, what we run, how long it takes. And similarly with the pre-submit time, and again, the reason that number has really fallen off the cliff is again a lot of the work we have done. We've had a big focus on speeding up our pre-submits. We took a lot of our flaky tests, slow tests. They get pulled out of pre-submits, so that's great. But that's nowhere as close to where we would want it. We would want, again, the dream about invisible tests. We want it to be there. Yeah, that's kind of, I think, the key things I wanted to highlight in this. Okay. Fish food. Dog food is a common industry term. We wanted to take it to the next level. Fish food doesn't taste great. It's yucky, hardly edible, but helps your immune system. And that's kind of what we mean by it in terms of using it for our product. You expose the pain, right? You share the pain, expose the pain. Like if you have bugs where you can't send an email or you can't make a post, there's a good probability whoever introduced that bug will also see it and they'll fix it. So this also helps with rapid iterations, right? You can iterate rapidly, and these are the early snapshots I spoke about. I don't actually sign up my teams to manually test this crap. I hope I can say crap in a public conference, yeah. Because there's a lot of moving pieces here. Again, the concept of hermetism and applied to manual testing. Yeah, I think the features barely, the moment a feature is implemented, like someone might have implemented the button but not implemented the action handler on the button, which means you see the button, but that will just do nothing. And if you expose testers to it, they'll log a bug, they I clicked the button, nothing happened. But that's because, yeah, it's getting implemented. It'll be there in the next hour maybe. So we actually we have no SLA from a test perspective, but this really helps us, have rapid iterations, rapid turnaround time. We've had like, more than often we have like 4 hours from like the time like a feature is thought about and you actually see it somewhat working. So I think it's pretty cool. Prioritize releases, right? And the way like the grass is greener where you put more water, essentially, right? If you don't prioritize releases, at the end releases is the way you get everything out. So you really, I mean, and you need to make postmortems. I mean, the thing at Google, postmortems need to be part of the culture. It's actually, postmortems are a great way to learn from mistakes and actually improve tooling, infrastructure, process. At Google, we actually have a bad postmortem of the month award. Actually didn't know that till 2 weeks back, till my team actually had to, we did something really bad. They said, but wait, you will probably qualify for that award. I'm like, sweet. Yeah, Google's great. All sorts of perks, I tell you. And it's also good, having on-duty rotation helps because everyone knows how the stack works. Every software engineer works in isolation and each are their part of the puzzle. And going through understanding how the releases work, give them a perspective of how the product works, which in turn, we have got most feedback from them really helps them build better features down the line. They think about implications up and down the stack when they go back to do this. So I think this really helps. Well, again, I spoke about so treat regressions as build blockers. And the best way the analogy for those of you who have done this is knitting. I did this years back when I was in school. If you make a mistake in knitting, what do? You undo what you've done and then you redo it. When I used to try to do knitting, I think I undid more things than did, which isn't possible, but it felt like it. It's kind of, this is a cultural shift, and I think it's important because like I stopped doing rollbacks. And one way to enforce this is I just started rolling code back. And I stopped doing it after I crossed about 1,000 changes because by then people got the idea that you should do this. And now we are tooling our continuous build system actually auto rollbacks code that doesn't compile or code that breaks more than 1,000 test targets. And we are actually evolving that into like more finer thresholds. But the key is, this is a guaranteed fix. Whereas if you try to make a speculative fix, it might fix one thing but cause another thing. We actually, at times, we favor, like the changes you want to roll back is maybe 4 changes deep in a list of changes. We actually roll back all 4 of them, and then we resubmit the top 3. So that still means that we have removed the buggy code and then we've essentially like back to where we were. And this gives people more time to react. You're not like someone's not on at their, especially if you ship daily, so no one has a gun on their hand and say, oh, you need to fix this and you better fix this before you go home and stuff like that. Murphy's Law. Anything that can go wrong will go wrong, and it does more than often, right? So this is the slide where I'm telling, as optimist a guy as I am, I'm like, we need to be a pessimist. Hope for the best, but prepare for the worst. Like this is where you put on your tester or there's your like how to break things hat, right? Imagine all the possible things that can go wrong. Some of the things which we have done here are things like we call it missing backends. Like we actually take a perfectly functional stack and randomly start killing servers. I mean, not on production, mostly. And see how the system behaves. Does it degrade gracefully? Like does the functionality which not depend on that part of the server actually work? So we actually have this, and in some cases we actually have it automated, so this continuously runs and helps us identify problems. I wanted to earlier this year Google had an outage where, and this is on the Google blog, but a bunch of services, Google Plus, Gmail, you couldn't, for about 25 minutes users couldn't log on, right? Because the configuration at Google was pushed, which tells other services at Google what to do with user requests. And the software bug caused the bad configuration to get pushed. And that caused the user request to kind of black hole and stuff. So we've taken that very seriously, and since then we have actually put in significant efforts around making sure all automated configuration folks, machine generated code, and we test it to the extent we can, because turns out you can't even trust that. Lastly, so this is like sangria. You can keep making the best sangria ever, but at some point you just want to drink the damn sangria, right? So, I don't believe in being a gatekeeper. I think I believe the test engineering organization is in a great position to provide a good risk assessment. We tend to get involved, our power users involved in helping us giving feedback, especially as we get closer to launch. We in fact have if you want to get on the Google Trusted Tester program, we'll try and circulate a form if you guys want to know something. That also helps us get very valuable feedback on the product, on what things we should do and shouldn't do. This is really where you have to balance how much you want to go velocity. We of course don't compromise on anything, ACL, security, data, stuff like that. The things which you can't compromise on. So, if you were sleeping so far, wake up, and this is essentially what I was talking about all this while, right? So, so for those of you who don't hate boring talks and don't like slide decks, this is it, really. I wanted to, just end, of course, the world is moving to mobile, and while I knew this graph would be upward, I was surprised how upward this graph is. So, I mean, this poses some interesting challenges and opportunities for us for our move fast and don't break things model. I think we need to make some adjustments. We need to rethink some of our tooling. For starters, you can't push daily to users. You can, but it'll be kind of lame. There's battery, data, there's network limitations. So I think also the state of tooling has to catch up and evolve in the state of web and server tooling. And I think at Google we have a big push for it. But I think we need to, it's a challenge to have blazing fast tests, especially when you're using emulators. We have come a long way in speeding up our emulators, but a lot more needs to be done. It's interesting to test automate battery testing, right? I mean, how do you, the moment you connect your phone to a machine, it's charging. How do you test the battery when it's charging? So we do it in a weird way, but so those are the kind of challenges. How do you do this in a way that scales? Integration testing has to be rethought, right? So this is actually an area I'm hoping over the 2 days you guys are here talking. I would love to hear thoughts, ideas, or we want your opinion. We want your thoughts on how you think things should be done in the mobile first world. We have a few things in flight, but again, I didn't want to make this a 3-hour talk. Also, I think we want to polish what we have a bit more before we share it with you all. I created this community. We'll see how far this goes, but again, I hope this discussion doesn't end here today. So I would love to hear thoughts and comments from most of you guys on how you do things. And that is it. This is my last slide. Yay. But another way to look at this is, in my opinion, it's not all about tooling or technology. A lot of this is there's a cultural element, and I'm involved here. And in my opinion, if you have to bucket these things into these 3 areas, there are things which fall into the cultural part, which doesn't require a single line of code or a single tool to be written. There's tooling. Some areas require tooling, and some areas a combination of both. So that's it. Thank you for not throwing any rotten tomatoes, but open to questions.
Thank you, Ankit. So do we have any live questions? Anybody want to come up?
Hi there. Good talk. Thank you. Can you clarify, when you do your release cycles, you said you start at 4 p.m. each day, and typically the team finds 3 to 4 defects. You back those out before you push to deployment, or do you fix those in place the next day?
So if I understand your question right, we don't start. There's a cut happening every hour. We just happen to take the one around 6 p.m., the latest one, and graduate that. We find 3-4 defects. We fix them on the branch, and then we revalidate, but we do it in a way like we don't revalidate everything. And then I missed the step when I was talking. We push it to staging too, especially for servers which have state. Because we can't, there are some corner cases which you only hit with when you expose things to millions of RPCs. And we let it sit on staging for a bit, and then we push it to prod. Okay. But at staging, there's a bunch of other metrics we go into, but that's a topic for another talk altogether. But yeah, I hope that answers your question.
Good, thank you.
I do have a question about your Hermetic tests, and I wonder, given if you isolate the dependencies by faking them out, that in itself creates risks. How do you manage the risk of making sure that everything will still run when things are not stubbed out?
So that's a good question. What we try and do is simplistic. Let's say a stack has 3 servers, and you're taking one and faking 2 out. What we essentially do is, in the old world, we would have one test where all 3 would be running. In the new world, we would have 3 tests, which essentially have one real and 2 of the other fake. So you are writing 3 tests, but we parallelize all these tests. So in essence, you're doing the same testing which you were doing with the one test, but you're parallelizing that. One of my teams has also come up with this interesting concept called cutover, and we actually are. We have a prototype ready where we are actually working on a fake which doesn't go stale. It's actually a pretty cool idea. The fake actually inherits a lot from the real server works, and it kind of keeps itself auto-updated. But that's kind of all said and done. There have been some instances where we have these 3 tests, and some stuff is still broken, but then that one test was still happy, still didn't catch it because it's just something. Depending on how deep of a stack you want to go to. I mean, Google stack is pretty, you can go 10 levels deep, but hopefully that answers your question.
Do you have any examples of enterprise level applications where what your application is doing is transactions kind of things? And then if you release in production, there could be a customer out there who is so unique in the kind of configuration that the customer has that you may not have covered in the possible scenarios in your testing, and then there is no way to roll back. You have to roll forward for the transactions.
No, and that's a good question. So overall, how does this map to the enterprise world where, well, there is a different risk tolerance level? The example, when on Gmail, we have paying customers, right? The enterprise version of Gmail. And for some of our big customers, we essentially created, we run all these tests in all the enterprise, like we don't, not for a specific company, but we run it in education mode, premier mode. So we actually have all this replicated across the different modes. And that's how we kind of, but yeah, there are these special use cases. But in general, I think Google's done pretty well, not trying to get too rattled into very customized enterprise hookups. In terms of transaction stuff, they still have Hermetic tests, but I think there we actually, at times some teams cut daily, they actually canary for longer, and they push, like they still have daily cuts, but instead of pushing daily, they push, say, every 3 days. So it's a risk and tolerance. Okay, I'm getting the placard. Thank you, guys. I would love to hear more from you guys over drinks later today, but thanks again.